Okay, so let's get through today's lecture. Today we're going to be doing a little bit more with TCPIP programming, but in a little bit different way than just making a connection and talking. And what we're going to talk about today is kind of the DNS system. All right, so let's go through this. This shouldn't take too long. Let's go through this relatively quickly here. All right, so the first thing that you may notice is that so far when we've written our kind of TCPIP programs, and when we've also looked at the underlying protocol, you notice that it uses these addresses. And specifically, we've been looking at IPv4, which has these kind of 4-byte addresses or 32-bit addresses that look like this. If we write them out in numbers and dots notation, they might look like this, or localhost. But we got these 4 numbers that range 0 to 255. And really, the 255 part of this is reserved for a kind of a broadcast address. That's 0 to 254. And 0 has a meaning as well. But the idea is that it's just these 4 bytes make up an address. But one of the things those addresses are what get put into the datagrams. Those are the part of the IP layer. You'll notice there's nothing to do with names anywhere in any of TCP/IP. It's all addresses. But addresses like those aren't the easiest thing to remember, but it is easy to remember names like google.com or reddit.com or eBay or I don't know, even things like Amazon.com. Notice that those are all names. Those are much easier for humans to remember things like names than it is to remember just a string of numbers. The other thing is that a particular website might move what physical server it's on, so they might switch the number around to be something different at different times. So in other words, maybe even for load balancing reasons, somebody might get one number, somebody might get a different number, so you want to spread the load out across multiple machines rather than having them all go to one number. So in other words, rather than remembering the addresses, essentially what we can do is we can have a name associated with those addresses, and that's what DNS allows. So essentially DNS, the whole point of it is to allow users to use names instead of having to remember the actual IP addresses. And they created this system called DNS, which stands for Domain Name System. Sometimes you'll hear it referred to as Domain Name Service. But the idea is that it's this kind of software system that associates a name with an IP address. And what it does is it stores those names in kind of this distributed database across lots of different servers. And the idea is when you type in some name, like google.com, it's going to do this kind of lookup of that and figure out what IP address is associated with that. And there's a very clever way that they came up with to go through and perform that lookup. All right, so the subsystem for DNS works as follows. It's basically just another network service. It has its own protocol. It's got its own servers that run much like a web server, but they're name servers. And the name servers, basically, you put in a name into something like a browser or try to do a name lookup through any kind of tool that you're using, and it's going to go through and have this single function call that makes this request that then gets resolved by the DNS system. And essentially, when you make that function call, that call to that function to say what address goes with this name, the function first looks on the local machine. And local machines can have addresses defined so that you put in a name, it resolves as a particular server. And that's pretty common, and it used to be common in Unix systems that you could set up your own local network, give the machines names. The names that you could put in there, you can associate addresses with, and so it'll look in that local kind of context first. If it doesn't find it there, then it passes it off to the defined name server for your machine. So your machine, for example, has some sort of name server address specified. It'll use the DNS, let's say, protocol to request from that server the actual name. Now that server, if it doesn't have the name, then it's going to return an address of who you should ask about that. And it doesn't really return it back to us. It kind of does it internally. It says, I don't have the name, so I'm going to ask somebody that's at the top level of this kind of root server, and it's going to tell me what address to go to for the next level down, and then that server is going to tell me what address to go to the next level down. and it's going to kind of recursively go through each of those layers until we get to the actual name. If the name doesn't exist, then we're going to essentially say the name couldn't be resolved. But it's going to kind of go through this iterative process of talking to multiple servers. And every time you do a name lookup, something like that happens. You ask, the local machine says, I don't have that. It goes to your defined DNS kind of authority. If it doesn't have it, then it ripples down from the top level all the way down to the actual place where the name server that has that is, and then it gives the answer back to the server you requested it from, and it gives it back to you. So there's a lot of stuff going on every time you do a name lookup. But once you have the name lookup and you have the IP address, you can use the IP address. Okay, so let's look at a little example here of what we're talking about. And what you'll notice here is we've got this kind of, let's say here's the client and it says, hey, I want to talk to google.com. Well, google.com is a name. It's not an IP address. So to talk to that web page, we need to find out what address is associated with google.com. So notice I labeled these steps with numbers that kind of label the sequence. So you'll notice here 1. So step 1 is google.com is not defined on the local machine. So it asks the defined DNS kind of resolver or server. And then what it does is it handles everything from there on out. So what it says is, I don't have that defined in me. So I'm going to start at the root DNS server. I'm going to say, hey, who's responsible for kind of the .com domains? And it's going to return to me an address of a server that's responsible for .com. And then from that top level domain server .com, it says, okay, I have a google.com. Here's who's responsible for google.com. And then once I have that, then I can go to Google's thing and say, what's the address that's associated with that? It's going to return that address back to us. And then that's going to be pushed back up to us. But notice from the client point of view, it doesn't have to deal with all of this other stuff over here on the side. I guess I should say, I don't know which way you're looking at that. It's backwards. But over on the side, it doesn't have to deal with any of this stuff. It's only going to say, hey, who is this? This handles contacting multiple servers, getting answers back, until we eventually filter down to the name associated with that. And you notice that they're under google.com, there could be subdomains as well, like www.google.com, mail.google.com. There may be a whole lot of other services underneath this google.com name that all have different addresses. But essentially we say, talk to the root server. It says, talk to this server for .coms. It says, talk to Google to get answers about Google domain names. And then an address comes back to us, or to the resolver, which passes it back to the client. And then we're done. Now, this resolver lives probably on some other system other than your system. It's configured in your network settings who your DNS server is. And we can pull that up and look at that if you're interested. But the idea is that's part of the configuration of your machine. In fact, you can use Google's DNS resolver if you want. You can configure your system to use that, which is the IP address 8.8.8.8. 8.8.8. Yeah, so 4 8s. That's the kind of Google owned DNS resolver. So you could actually request or configure your system to talk to Google DNS resolver, and it will give you the answers back. Now, one of the things is all of these connections might not happen every time. A lot of the way these things are written is they do employ sometimes a caching mechanism, so they'll keep track of, hey, somebody just asked about google.com. I already know the answer to that, so why go through contacting all these and add extra traffic when you just pass that up, and they'll maintain caches of those things so that performance is improved and traffic is reduced. But the idea works exactly like this. Now, notice I've left off of this diagram actually contacting the website and downloading the data, because once we have this, we now have an IP address that goes with google.com. And once I have that IP address, then I would the web browser will talk to that IP address and to perform the actual communication. All right, so in code, we need to kind of make the single function call to get an answer to this. And we're going to look at two different ways of doing this because you're likely to encounter them. One is considered kind of the old way, and then there's kind of a newer way that kind of is supposed to be supplanting this. But I still see a lot of code using things like this. So the idea is we're going to use this gethostbyname function. And we pass into that kind of the address that we want to resolve. And we'll look at how this works in a second, and it returns the result. So that's going to return a structure that contains the address and some other potential information associated with the name. And to get a better feel for what gethostbyname does, let's look at the man page for that. And I've extracted some portions of the man page here, like I did previously. But notice gethostbyname, that same man page also talks about gethostbyaddr. So you can actually put in an address, get a name, put in a name, get an address with these two different functions. Now notice the gethostbyname is pretty simple. We just pass it a character pointer or a pointer to the string, the C string that holds the characters that make up the name. So in our case, that would be like a pointer to the start of this character array, GOOGLE period COM, and then a null character at the end of that. So we're passing in this name, and it's going to return to us an address or a pointer to a structure of type host int, which is a host entity, which we'll see. Both of these, notice, return the same thing. One of them we pass in the name, the other one we pass in the address and the type and the length of that address that we're passing in. All right, so looking at the description, it basically says gethostbyname returns a structure of type host int for a given host name. Here, name is either a host name or an IPv4 address in standard dot notation. So we can pass in actually a string that's the address, the numbers and dots notation, or the host name. And it will look it up and give us the same kind of thing back. So you could pass an IP address into this as well and see what it returns. You could pass in a name and see what it returns. Okay, now, one thing to note, both of those functions return the same kind of structure, pointer to the same kind of structure. All right, so let's go ahead and take a look at that structure. So that structure basically it returns, this is what gets returned, a kind of address of one of these things that's been allocated for us to look at. But you'll notice that the first thing is a pointer to the actual official host name, and then a pointer to, essentially this is an array of character pointers for aliases. So in other words, if this name has other names it goes by, those will show up in this. So for example, you might have google.com, and then you also might have search.google.com or s1.google.com. So anyway, the alias is a list of other kind of names that this thing might go by. And notice it's not just one single one. This is a pointer to an array of these. And we'll talk about how do we know when the end of that array is in just a second. And then we have the host address type, the length of that address. And then down here, we have the list of addresses. So this, if I pass in that one name, it's going to say, hey, this is the official name of the thing you looked up. Here are any other names it might go by. And by the way, here is an address. And notice that there's this pound define as well, that h_addr is defined as addr_list0. That's the first one in this list. The idea is that the first one in the list should be the address that you actually use for that. And then down below, we have a few. Oops, let me go back for just one more second. So down here, we have kind of names of those, but there's something I want to look at here. Notice the aliases. We said we were going to talk about how do you know when you're at the end of that, since that's just a pointer to an array of these. How many aliases are there? Well, that array of alternate names is actually terminated by a null pointer. So in other words, this is think of this as an array of pointers. When I get to an element in the array where the pointer that's in that slot in that array has the address 0 in it, we know we've reached the end of that. That's not a valid alias anymore. Notice the same thing is true for the address list here. If we look at that, an array of pointers to network addresses, notice it's in network byte order, terminated by a null pointer. So in other words, this is the same thing. This is a pointer to all of those things in that list, eventually ending with the kind of null pointer. Now, one thing about that is in the man page, this is listed as a character pointer, but these are really the kind of address structure type. So these are really pointers to kind of these address things, not really a string. So this is not numbers and dots in here. This is kind of the raw data. And we're going to have to change that if we want to print that out or display that in some way. We have to change it back to numbers and dots. So we'll talk about that here in a second. All right, so moving on. The return value of that function, by actually both of those functions, is the host int structure. There's a T missing from there. The host int structure or a null pointer if an error occurs. In other words, it's returning an address to us. If it returns an address of 0, it returns a null pointer, then there was some kind of error. Now, what kinds of errors are there? Host not found. You try to search for something that doesn't exist. It'll go through the whole process, and then eventually the resolver will say, I don't know who that is. I can't return to you the structure of addresses because I don't know what addresses go with that name you asked for. There are also some cases where, for example, there's no data that was returned. You found the name, but it didn't have a defined address with it, so it'll say no data. So in other words, I found something for that host, an entry in the DNS, but it didn't have an address associated with it. And then there's some non-recoverable error. I've never actually encountered anything that caused that. I'm not sure what would cause that. And then there's another one that says maybe something's too busy, and it says, try again later. So we could get that. So the most common one, obviously, is you try to look up a host name that doesn't exist, and you'll have that returned. But you can tell that because you'll always get a null pointer, and then we'd have to look at this global variable to see what caused it to be a null pointer. Okay, so let's look at a quick example of some code that actually does a name resolution here. And so in this case, you'll notice a couple things that this is for Linux, Unix. If you wanted to do this in Windows, you'd have to include winsock2 instead of these things. And the other thing in Windows, you'd have to set up the do a WSA startup, WSA cleanup at the end, and surround all of this by that. But the gethostbyname function exists in Windows just like it does in Linux and Unix. Again, Microsoft kind of copied the way a lot of that already worked in Unix when they implemented their networking, so they pulled that function into it. So the idea is, again, we call gethostbyname. We pass the string of the website we want to look up in. It returns this host int structure. Notice I declared this as a struct host int pointer called h_int. So in other words, I'm just assigning this pointer to point at whatever was returned, whatever the address that was returned by this. So inside this function, it's going to allocate that host int structure, and then it's going to return the address of it to us. Now, that's going to create a little problem that we'll see here. What's one of the reasons why this is deprecated, or why there's a new way to do this. But looking at the rest of the things, the next thing I do is I essentially go through all of the aliases until I get to the null pointer. So in other words, I'm just going through each of the aliases in the array one at a time until I get to one that's null, which indicates the end. And what I do basically is I print out the alias. %s is the string that's in that thing. So those are actually just strings that have all the alias names. So I just print out those %s's for a string. So this would say, for example, alias 0, print out the thing, alias 1. So in other words, I'm saying of all the aliases, what spot in that array has what value, and I keep doing that until I get to the one that's a null, and then I stop. And then I do the same thing down here, but I'm doing it on the address list. In other words, I'm going to go through the address list until I get to a null. But when I print that out, remember it was in the kind of raw 32-bit network number terms for IPv4, the way it's stored in there. So I have to use this function to convert it. So inet_int to a. One of the things I have to do, though, is the inet_int a expects a structure of type in ADDR, and I don't have that. If you looked at the man page for this, it had a character pointer for this thing. So what I have to do is cast that as struct in ADDR pointer, and then get the thing pointed to by that, which is now the actual structure, which is the right type now to pass to inet_int to a. And N to A stands for internet number to ASCII. So I'm taking the IP address number, the 32-bit number, and converting it into the numbers and dots notation, which then this produces a character pointer as a result, or a string, null terminated string, which now the %s works on. So this will print out all of the aliases. It'll print out all of the addresses for yahoo.com. All right, so that's how to do it kind of the old way. And notice we only had to do this one single function call, and now we have the address that we want and other possible addresses as well. And one of the things you'll notice is some websites, when you do this lookup, you'll get in this addresses, you'll get a whole list of addresses. And if you call that once and then call it again later and call it again later, the address that's at the top of the list might be different. And one of the reasons for that is that's one way that they do load balancing on servers is by changing the address that from DNS that it resolves to, or the one that's at the top of the list, because that way you can say, I'll give this one out, but if the server load gets too high, I'll give out a different address. And if that one gets too high, then I'll give out a different one. So you might see them rotating through different addresses at different times by having their DNS server change the order that those are returned. All right, moving on. So get host by name, get host by address, pretty simple to use, but that's considered to be the old way to perform DNS lookups. The new way is to use these new functions, which are getaddrinfo and getnameinfo. And those kind of do the same things that these two do, but they're considered better for a couple reasons. One is they're reentrant, which means that one of the problems with these, let's go back for just a second here, is notice that this, if it's going to return the address of one of these structures, it has to have allocated that structure inside this function itself to return the address to it. And that means if I had two threads that were both trying to do a name lookup using this function, that if that's allocated internally in here, that's not going to be reentrant. We could have one accidentally overwrite the other. So we can have this concurrency problem that happens here. Now, if you're in the same or different processes, it doesn't matter. But if you're in the same process with two threads both trying to do name lookups, then that could be a problem because the allocation is stored inside of the function itself, and it's just returning a pointer to that rather than the entire structure. So that creates a problem that it's not reentrant. Reentrant means that we could call it once, call it again, and not have it mess up the previous call or this one because we were already partway through that function. All right, the other thing that these new ones do is they kind of combine the functions of getHostByName and getServedByName. And getServedByName is kind of getting the local server data. But the idea there is why have two different functions when we can have one? And so the newer functions also kind of make it easier to deal with both IPv4 and IPv6 dependencies, which it's becoming more important to support IPv6. IPv4 being only a 32-bit number limits the number of addresses that we can have. And so they started to run out of IPv4 addresses, so started transitioning to IPv6. And the function, while those previous functions work well for IPv4 addresses, there were extra things you had to do to get them to work with IPv6. It's kind of added onto those later, where getaddrinfo and getnameinfo, those ones we can access either IPv4 or v6 very simply through the same function without having to do extra steps. All right, so let's take a look at the man page for that. One thing before we do that, though, interestingly, behind the scenes, getaddrinfo is still calling and doing the same kinds of things that this was doing. It's just a different interface to those things, a little more abstracted. All right, let's look at the man page for that. So the man page for getaddrinfo, also notice there's free addrinfo, and then there's this GAI str error. We're not going to worry about that one, but this one, the free addrinfo, and that is going to be something that we need to do. So let's start with getaddrinfo, but notice we pass in this node pointer, we pass in this service, character pointer service, and then we have this pointer to a structure of type addinfo called hints, and then one that's a structure addrinfo pointer called res, which is kind of results. Okay, now the stuff we're passing in are these first three. The results are going to be in this last one. So it's going to still allocate that and return that to us, and then we have to free it. So rather than having just one that's shared, it allocates a new one every time. We have to free it using free addrinfo. All right, so let's read a description here. It says, given node and service, so node and service, which identify an internet host and service, getaddrinfo returns one or more addrinfo structures, each of which contain an internet address that can be specified in a call to bind or connect. So bind and connect is what we did to set something up for either a listener to listen, or set something up to be a client, so server or client. So this would be for servers, this would be for clients. The getAddr combines the functionality provided by the gethostbyname and getservedbyname. We talked about that into a single interface, but unlike the latter function, so unlike the old way of doing it, it's reentrant. We talked about that, and it allows the programs to eliminate IPv4 versus IPv6 dependencies. So those are all good things. So that's why they suggest using the new one, is it makes this transition easier, or supporting both of these easier, and it's also reentrant. So if we have it in a thread, it won't create problems for us. Okay, so let's go on. Now, just like the old way of doing it, it returns a structure. The structure, however, looks a little bit different, and it basically has this AI stands for ADDR info, flags, a family, a socket type, a protocol, this address length, this pointer to this AI ADDR structure, character pointer for the canonical name, and then this pointer to another one of these same things. So notice this is actually a node in a linked list because it's a pointer to the next one in the list. So rather than it being this null terminated array like what we had in the old one, it kind of still is, but we have to traverse the elements of a linked list and get to a point where the AI next is null. So when that becomes null, we know we're at the end of the list. So it's not quite the same as an array that has a null pointer in it. This is a structure that points to the next structure, that points to the next structure, that points to the next structure, and so forth, until we get to one that has a null at the end. Typical linked list implementation. Okay. Now, I'm not going to go through all of the text on this. If you want, you can pause the video and read through that, or you could just pull up the man page and look at the man page yourself. But the idea is this is about the hints structure. So the hints argument points to an ADR info structure that specifies the criteria that we want to use for our lookup. So in other words, we can put things into hints that tell us, you know what, I only care about this kind of address or this kind of information or this kind of stuff. So in other words, notice we can fill those into, let's go back to that structure for just a second. So we can fill in the family or the type or the protocol, and it will only give us results for that family and that type and that protocol. But notice also it says that you can also pass hints in as null, which gives you all of the things in that that match all of those. So in other words, null is kind of like a wild card for everything. But if we pass something that's not null into it, then we can specify a family or socket type, or we could leave these null to give us a wild card in those positions. So it gives us this flexibility for how we want to perform the lookup. So if we want only IPv4, we could put in AF_INET. It'll give us any of the IPv4 addresses for that thing. If we want only TCP services, we could put sock_stream in there for a socket type. All right, and the rest of this we're not going to worry about too much right now. But one thing I do want to point out is this last note here. All other fields in the structure pointed to by hints must contain a 0 or a null pointer as appropriate. So in other words, we need to fill it in with, if we're not interested in that being part of our match, we need to put a null where it's a pointer or a 0 where it's some sort of constant. Or remember, we could specify the entire thing as null, which is what it talks about here. So specifying hints as null. So there's hints. So if we specify as null, it's equivalent to setting the socket type and AI protocol to 0, the family to unspecified, and the flags to this set of flags that we have here. And so note that you can do that. Now, notice there's a little bit more information here that you can look at if you want to. This is about node and service. Node and service. So let's look at that. Let's start off with node. It said node specifies either a numerical network address in numbers and dots notation. So we could put in an IP address there. or you could put in a network host name. So this is where we're going to put it. That's a character pointer. So this is going to be a string that's either like numbers and dots in the string, like 146.85.1.1 in quotes, or it could also be something where it's a name, like www.google.com. So that's where you're going to put in the information that you want. And service basically says it sets the port in each returned address structure. And that service, essentially, that can be specified as some decimal number for what kind of service we want the address of. And that basically allows us to specify, find something on this particular port. And notice that it says either node or service, but not both may be null, because otherwise there's nothing to look up. So we're either looking up a service or a node or a name and a service, but we can't look up nothing here because it doesn't make any sense. Okay. All right, so how does it produce its results? Well, it allocates and initializes that linked list of structures, one for every address that matches the node and or service that we requested. And basically what it does is it just returns that pointer to the start of that list to us in that RES position, the result position. So if we want to go to the next one, the next ones are all linked in the next AI_next field. So it's just a typical linked list. It returns to us a pointer to the head. And then if we want to go through the rest of the list, we have to go through it ourselves by going to the next thing. And notice that you could actually iterate through that or recursively go through that list to go through all of the addresses that get returned. All right, as a quick reminder, this is what the ADR info structure looks like. There's the next pointer. All right, so let's look at some example code for this. All right, so example code for this, the first thing is, again, notice this is Linux/Unix. If you want to do the same function in Windows, you would, rather than put this stuff in up here, you'd put in kind of, again, the winsock2.h. And then in addition to that, you'd have to do the WSA startup, WSA cleanup at the end around all of this other stuff. But the function would work the same in that. All right, so looking at the function getaddr.info, again, we're passing in the name in the first position, null in the service position, nothing in hints, and we're just going to get the result. And we're passing here the address of this ADR info structure result up here. Now, why are we passing the address into that? Because this function needs to allocate that and change the address that's in that. That's why it's passed in as a double pointer. And if you remember back to systems programming class, we had the same kind of thing when we dealt with linked lists in there. So we're passing the address of a pointer in there so that this function can fill in that address and change it to some other address. So that it's going to allocate the data for us, put the address of that into this. So now we can access that through this result position here. All right, so we look that up. And if that returns something that's other than 0, in this case, so 0 means success, something other than 0 means failure, we're just going to print out that there was an error and then return from the program. Really, we might want to, this is in the code where we say couldn't find that or address not found or something like that, but we did it by doing that. Now, continuing that code, now we have a loop that I'm using. Let's go back for 1 second. Notice I have 2 of these variables. One of them is the result that was returned. One of them is the pointer I'm going to use to move through the linked list. And the reason I could do it with this result up here, but then I would lose the head and I could never use it again later. I would completely lose that. So what I did is I created another sock ADDR info pointer, structure pointer, and I'm going to use that to kind of iterate and move through without disturbing the actual result that we had here. All right, so let's look at how I did that. So basically I said start off the second pointer as the first one, and then continue while it's not a null pointer. And then every time I get through the loop, update it to the next, so it changes it to the next one. So that the next time through the loop, it's going to be the second one in the list, and then the third one in the list, and the fourth one. Eventually, we'll get to a null, and then we'll stop. Okay, so going through this, essentially what I did is I switched based on the address info family. And I just have a few of these in here. I just have IPv4 and unspecified. So I'm going to print out if it's unspecified and then go to the next one. The next one here, if it's IPv4, I print out the address that's associated with it, again using this inet into a thing. I take this address, cast it as a struct sockaddr in, put it into that variable, and then I pass that to inet10.8. Now I could have done this all in one line. I chose to break it apart into different sections here so it would all fit on the presentation. I originally had it all as one line, but I think that we take this address. We take this address. Something just happened to the microphone there. Hopefully we didn't lose audio. We take this address, cast it as that type. That's what this thing actually has a pointer to. We pass that address into the inet_a function, which is going to return a string of the numbers and dots notation for that. And then my default here, I just say not an IPv4 address. If we wanted, we could have a case for IPv6. We could have a case for NetBIOS. We could have other cases in here in my switch to print out those other addresses in whatever way they need to be printed out. Okay, but now one important thing here is notice at the end we need to free that result because it's been allocated. It's been dynamically allocated for us, so we need to free that. And then we return from the main program at the end. If we don't free that, and we do this in some sort of program that runs over and over, we're going to end up with some difficulties with some sort of a memory leak. All right, so continuing on. Again, remember to always free the results using free_addr_info. Pass the result into that, or the address of the variable that's holding the address, and it will free that data for us. If we don't free those, we could create a memory leak, especially if you have a program. So every time you do a memory lookup or a name lookup, DNS lookup, you would lose some memory and lose more memory and lose more memory. And if you're doing that inside of some kind of program that runs in a kind of repeated fashion, then that's going to end up creating a somewhat severe memory leak over time. And we don't want that. So always, if you call that function, always call free_addr_info at the end once you're done with it. All right. One thing to note is that there are other possible results that are returned with different family types. So you could get IPv6, you could get NetBIOS. There are other ones you could get depending on the system you're on. But, oops, didn't quite finish that. So any program that you use takes uses some domain name. It takes it, like, for example, let's say Firefox or Chrome or Edge or whatever browser you type in an address you want to go to. It has to be performing a DNS lookup using one of those kind of functions like that. And then the idea is behind this lecture is now your programs can do that too, and actually multiple ways. The old way, if you see that being used somewhere, you understand it, and then the new way. And notice that they really aren't that much different from each other. They're both returning kind of the structure. The only part that's different is how we request that, and then how we access that data inside that structure is a little bit different. But it doesn't take a lot of code for either one. And the idea is you can now write code that does it too. So rather than having to specify IP addresses in your code, you could look up, do a DNS lookup, and then use the domain name and connect that way. Now, if you want to set up your own domain names, you can certainly do that to your own servers. But remember that you have to get your domain name registered in one of those in the DNS system as a server. You can also run your own DNS server if you are at a point where you have a lot of machines that need to handle a lot of things. You can actually set up your own DNS server and edit a file, reload the system, and then you can change those names around on your server. Or you can have somebody else put it into their server, which is usually why you have like a name registrar or something like that. We say, this is the IP address I want. This is the name I want associated with that. So whenever anybody does a name lookup, they get that IP address. But the idea is it's really just taking a name, converting it to an IP address. So that's what gets put in the datagrams. The datagrams never have those, at least not part of the header structure. They don't have the names. They only have the addresses. So this is kind of a layer that has to look that up before we can actually make contact with a web server or some other service like that. Okay, so that's it for today. Everybody stay safe. Next class, I think we'll have a lab where you get to write some code that does what we just saw here today. But until then, everybody stay safe and work on your previous lab. Try to get that one done because we're going to have more lab time next class. All right, stay safe.